this page, we're going to go through building the unit circle. So before we start building anything, I just want you to take a look at this image that I'm zooming in on. Just take a second, look at it. Think about what you know from geometry that might help you to kind of know a few more things just about this picture. Don't worry about the words or anything else on the page. Just focus on the picture. What do y'all notice? I'm not going to pick on people. They'll tell me. What do you notice? Jorge? Okay, what kind of special triangle? Okay, which means that both of the base angles across from the 90 degrees, so down here, have to be what? Equal. So the two angles here are going to be 45 degrees. Perfect. What else can you guys tell me? Okay, it looks like it's about 1/4 of what?
I mean, like 1/8. So
like. When you said 1/4, what did you mean? Like 1/4 of the entire circle, or 1/4 of just the top part of your circle? Okay, just the first half of the circle. Okay, so you're kind of relating it to what we've already done. That's cool. What else can you guys tell me? When you said isosceles, I thought of something. You said that your angles here had to be the same. What did you say about the side lengths? The side lengths have to be the same. So these two sides have to be the same. Okay. There's one other thing that I want you guys to see here. Not just Jorge. If you look at this line here, that's the hypotenuse. What can you tell me about the hypotenuse? Think about it on your circle. It's the radius. Why is it the radius? Where is it going from? It's going from the origin, which is the center of your circle, out to your side. This is a radius. We've talked about the unit circle, and we've talked about the radius before. What's the radius for the unit circle? 1. We talked about that several days ago. Not on this page. Sorry about that. Talked about it on this page. The unit circle has a radius of 1. So guys, just take a second and look at things. You'd be surprised what you can tell me about this. So with what you already know a lot of this. The radius equals 1. We know that it's an isosceles triangle. It's a 45, 45, 90 triangle, which means both of these angles, these side lengths, should be the same length. Okay, so now I'm going to put this to where we're going. This is on the unit circle, and I want you to see how this triangle on the unit circle relates to this image. So with the 45, 45, 90 triangle, let's figure out what these two side lengths are going to be. I know they're going to be the same, but just for the purposes of writing this in our notes, we're just going to use x and y. We know that x is going to equal y. They're going to be the same, but I'm just using two different variables. What is the pattern I told you guys to use when you have a 45, 45, 90 triangle? 1, 1, square root 2. Let me zoom out a bit. So we have 1, 1, square root 2. Right across from each of your 45-degree angles is an unknown variable. So we're going to put x and y. Right across from this 45 is x. Right across from this 45 is y. Across from your 90-degree angle is 1, which is your radius. We talked about this, and we've even had quizzes over this. We're going to solve. Solve for x and y. By finding one of the variables, you find both. So I'm just going to use this one here, just because it's already close to each other, and I'm just going to solve, because I know that x is going to be the same for whatever y is. So 1 over y is going to equal the square root of 2 over 1. How would you solve this? Cross multiply. So y times the square root of 2 is going to equal 1. I'm going to divide both sides by the square root of 2. And I have y is equal to 1 over the square root of 2. I mean, technically this is a number, but I like for you guys to rationalize your answer. So when I rationalize something, Odalis, what does that mean that I have to do? You're good. So this will give me the square root of 2 over just 2, because the square root of 2 times the square root of 2 is the square root of 4, which is just 2. This is my y value. What does that mean? It's the same as a what? It's a side length, but it's the same as what? Look at your graph. It's the same as x. So x is also going to equal the square root of 2 over 2. Because you know it's an isosceles triangle. I'll zoom out a little bit more. So on this graph, for where we're going, this point, which is on your unit circle, is going to have a coordinate of x comma y, which is the square root of 2 over 2, comma the square root of 2 over 2. If I asked you to give me 45 degrees in radians, what's the radians for 45 degrees? Pi over 4. That's exactly it. All right, cool. Let's look at the next one. With the next one, I'm not talking about anything crazy unit circle-wise. We're just going over things we already know. In this middle section, we're going to do the same thing. So in this middle section, just take a second and look. We already know a few things. Enya helped us tremendously with telling us that the center to the side of your circle is your radius, which is equal to 1. We have 30. What's this angle going to be up here? 60. Is that a special right triangle again? Yes. So we have a 30, 60, 90 triangle. With your 30, 60, 90 triangle, Valerie, S, what's the pattern that we use? Oh, you're good. Yes, 1 square root 3 and 2. That's exactly it. So using this pattern, we need to find the same things. We're going to find our side lengths. We already know that the radius is 1, which is your hypotenuse, because it's directly across from your 90-degree angle. But the other sides I don't know. So we're going to say that this side is x, this side is y. I'm just giving it variables, guys. I'm not being preferential to anything. Right across from 30 is y. Right across from 60 is x. Unfortunately, once you find x or y, you can't just make them both equal. You have to solve both. So for this question, you're solving two equations. 1 over y equals 2 over 1. Solve that. And then solve the square root of 3 over x is equal to 2 over 1. Solve that one when you're done. So I'm going to give you about a minute. Solve both of them. What do y'all think of my x and y? Do they look like yours? Okay, cool. So this point up here is at the same point whenever you're looking at your x and y. That's the coordinate. Square root 3 over 2, comma 1/2. I forgot to mention this on the last part of your question, but I'm going to do it now. This is, again, going from the center to the side of your circle, right? So keep in mind, this radius is still 1. I'm going to do that for this question up here as well. Your radius is still equal to 1. That's not changing. It's still going from the center out. The last thing that I need is 30 degrees. Joseph, what's 30 degrees in radians? I'm glad you don't remember. Because how can you find it if you forgot on a test or quiz?
Just divide it.
Not just divided into thirds. Giselle, what were you saying? Pi over 180. If you forget, and this is honestly something that I want you guys to write out, in case you forget what 30 degrees is in radians, because there's so many things I'm throwing at you right now, use the conversion that we talked about on like the second or third day. 180 degrees equals pi radians. This will always be able to help you if you forget or draw a blank on your test or quiz. If you do this work over here to the side, I'm not going to be mad at it. So I know the degrees are going to cancel. This is technically 30 over 180. Sorry, 30 pi over 180. Joseph, let's try that again. What do you think the radians are going to be now?
Pi over.
Let's see. Divide them both by 10. You can do that. 3 over 18. What's 18 divided by 3? You can do that.
6.
There you go. 6. I knew you knew this. Pi over 6. So 30 degrees is the same thing as pi over 6. If you forget the angle measure in degree, or excuse me, in radians, do this conversion, guys. It'll help. So right now, I want you guys to finish this last part. I'm just going to write out what your answer should look like, and we're going to be done. So I'm going to give you guys about 2 minutes, 2 or 3 minutes. Do this completely, all of it, every single part. Is this what you guys got? Okay. 60 degrees. What is that in radians?
Pi over 3.
Pi over 3. And the radius in this is still 1. So with all of this stuff, we've actually looked at pretty much like the first quadrant on how to actually find different coordinates within the unit circle, but we're going to continue this over the next couple of days. Are there any questions about this?